Good afternoon. Everyone have a good lunch? Yeah. So we've kind of got the 3 o'clock session where when there's a good lunch, it's kind of, I'll be watching to see all those heavy eyelids kind of fall down as everyone starts falling asleep, because we are obviously doing a design session on Hyper-V. Awesome product, but sometimes design sessions can be, we'll try and make it as exciting as possible. Anyway, my name is Brendan Byrne. I'm a senior consultant with Microsoft Services in Auckland, and this is...
My name is Lloyd Lim, and I'm a senior PFE in Microsoft, based in Auckland too.
Now, I do have a problem because I had a Windows session this morning, and I'd asked my wife to help me basically get across that in Microsoft Services, I kind of wear a lot of hats. So I'm a virtualization person, I'm a system center person, I'm a Windows person, and so I needed her help. So last night she kind of helped me out, and then this morning, just before the session, she sent me something to add to my my PowerPoints, and unfortunately it was actually quite embarrassing. And since I love my wife, I really need to just show it, just so she didn't waste her time. But I have added something just to embarrass Lloyd as well. So obviously, I don't know why my wife did that, but anyway. But Lloyd in the office is called Lloydopedia. So if you've ever got a technical question, we've got internal kind of forums. You ask a question and you always get, some random answers from some people, but you always get the full technical, detailed answer from Lloyd. So his internal nickname is Lloydopedia. For me, this must be my virtualization hat. Oh, right. No, we're not going to ask you that. I was going to put a random question in there and see if Lloyd could actually answer it. What's the agenda for today? We're going to be talking about Windows Server 2012 Hyper-V, or our cloud infrastructure. Microsoft terms, often when we're talking about private cloud, we'll talk about the fabric layer, and then we'll have the fabric management layer, which will be your management tools like System Center. Also, we're going to look at the considerations that you've got when you're building this Hyper-V infrastructure, or this cloud infrastructure. And the things we'll look at are things like workloads and networking, storage, the types of different resilience. And towards the end, we'll just go into some configurations. There is no one-size-fits-all as far as designing for Hyper-V. There's going to be different situations, different requirements that you've got for your workloads that you basically have to work around, and different technologies are going to work better in different circumstances. So it's not a one-size-fits-all. So what we're going to do is we're just going to take you through some scenarios, and hopefully it'll just help you understand when you should use some of the technologies compared to others. So 2012 is definitely our cloud-optimized platform. If you look at 2008 R2, it's our server virtualization platform. But this is definitely cloud-optimized. There's a few things that we're just going to consider here. When you're building a cloud, usually one of the key tenets that you're looking at is multi-tenancy. Now, in the New Zealand market, maybe not as much of a requirement. Maybe if you're a hoster, you're definitely into multi-tenancy. Maybe if you're a large enterprise, you might want to have separation and isolation between departments. But generally, small, medium, even some large businesses, they won't need the multi-tenancy. Who here would kind of have a multi-tenancy requirement in their environment? Yeah, so there's a few. Yeah. Yep, I can see that. Some of the hosters. So you have to be able to run different workloads side by side, and also make sure that there's boundaries or isolation between those workloads, both as from a security point of view and also from a performance point of view. Second thing we need to look at, or the second tenet we kind of have to look at, is the fact that it needs to be highly scalable. And as well as, in the instance of being able to scale up, also you need to be able to manage those costs. You don't want to get into a situation where you start to scale and all of a sudden it's costing you more. So one of the key tenets is making sure that while you scale, you can keep the cost low. And then also, it needs to be manageable. Okay, we scale it, the clusters get larger and larger, and we need to make sure that they're easily managed. and extendable, and we'll talk about extensibility later. So if we look at like a summary of the cloud enabling features, we can kind of put all the features kind of into those three different pillars that we just looked at. So the first one is all around that multi-tenancy. You know, we look at, you know, virtualizing different layers, whether it's storage or network. We look at isolation, so we can isolate different workloads or different tenants. We look at quality of service to make sure that certain types of traffic are going to get the bandwidth they require, and at the same time being able to get performance metrics on those things. Also cross-premise connectivity, so maybe you're building a private cloud or just a Hyper-V infrastructure. You know, some people are a bit scared by the whole cloud thing when they talk about, you know, doing cloud in their environment. But then maybe you're looking at putting different workloads into the cloud, maybe public cloud or maybe hosted private cloud. So that's when a hoster basically hosts your private cloud. Next thing we do is we look at the high scale and low cost. So really what we're looking at is, you know, creating bigger VMs on bigger servers. And we're making sure that we can use all the hardware acceleration that's available to us to make sure that we're running the platform as efficiently as possible. Last thing is manageability. One thing, I don't know whether you've been to any other sessions, but one thing, if there's anything that you want to upskill on, it's PowerShell, okay? PowerShell has gone from like 150 commandlets or you know, down and around that low number to about 2,400. So there's not much that you can't automate. People say that you can automate everything. I'll believe that when I see it, but I'm sure you can just about automate everything. And when you're looking at manageability, automation is very important. Okay, if you're going to manage a large environment, you don't want to have to do everything manually because then obviously human error slips in. So you want to be able to make sure you can manage that environment easily through automation. And extensibility, we'll talk about the Hyper-V switch later. Yep. Is it changing? Right. So this is the private cloud reference model that is freely available off the Microsoft site. Really, it shows you all the different layers in the stack when we talk about private cloud. So you can see there's, you know, the infrastructure layer, platform software layer, service delivery layers, infrastructure management layers, and service operation layers. So what we're actually talking about today is really just that part of the infrastructure layer. We're not going into you know, the system management layer or the fabric management layer. This isn't a System Center session, so if you've come to hear about System Center, we'll turn our back and you can walk out of the room. We're really just talking about the hypervisor and the underlying storage, compute, and network. Let's install them all. 2008, there was limited options as far as how you configured things. Okay, if you're talking about storage, it was iSCSI or it was fiber. And when you kind of considered that, it was like, okay, iSCSI means I need more NICs, and so not many people did iSCSI, it was always fiber. So the decisions were quite easy to make. Now you get into 2012, and there's a considerable amount of new features that have been livened up and new technologies that we can hook into, more hardware acceleration we can make use of. And each of them kind of has specific requirements or it's needed for specific situations. So you might think to yourself, oh, how do I navigate this maze of all these new technologies? And that's kind of what we're here to help you do. Like I said, it's not a one-size-fits-all. I'm not going to give you at the end one of those Hyper-V architecture posters and say, this is how you should do it. But hopefully we're just going to help you answer the questions yourselves when you get to the point where you're actually starting to design and putting these clusters together. So the question is, how would I build my cloud? You know, what are my requirements? What are my cost constraints? what type of scalability do I need? What kind of reliability is required? What are my security considerations? What are my performance considerations? What are my high availability considerations? You've got all these questions that you need to answer, and they really get kind of mapped into these 4 areas that we talked about before. So we talked about the workloads. What am I going to run on my cloud? Is it just going to be a whole lot of just kind of standard virtual machines, or are we going to run some really high-end workloads? Are we going to, run SQL and SharePoint and Exchange on there? Each of those different workloads are going to have different requirements when you look at the clusters. And I wasn't supposed to click the button then. What is the networking infrastructure going to look like? Okay, not just how many NICs do I need, but what type of networking am I going to use? How am I going to connect? Sorry, I just keep pressing the button by accident. Obviously not programmed right. How am I going to connect my Hyper-V hosts to the storage? And also, what type of resiliency do I need? Are the apps kind of resilient? So if hardware underneath fails, will the app keep going because the app is looking after the resiliency? Or do we have to look at the infrastructure side? So we're going to kind of just put it into those 4 main categories, and let's talk about workloads. You want to click it?
All right. Okay. All right. So let's talk about workloads. So first off, look at the various things we think about when we look at workloads, right? So you have got, is it cloud aware? Is the workload itself stateless and aware? In other words, let's give an example, Active Directory. If you lose one domain controller, the clients know how to find another one for most things. There are some things that don't work, of course, the FISMO roles and all that. But other than that, you find that most things will work even when you lose one. So therefore, I don't have to keep that VM running all the time if I don't need to. So I can host it on cheaper environments, and therefore I can save my cost on it. So there are certain apps that have this ability. So in that situation, you get that ability. Next, what are the requirements that you have in there? So you may have requirements that says that we want to have the best ROI we're going to get, and that means that we're going to run it on 2 CPU servers. Because 4 CPU servers are more expensive, and by the time you get to 8, they're a heck of a lot more expensive. So we don't want to go all that way, right? So in that scenario, what does that mean? How should we plan our infrastructure so that for the workload that we need, we can run it at the lowest cost possible, correct? Same thing. What about your apps? Certain apps have very high network requirements. Certain apps have very low, but very high CPU. So stuff like that determines your entire workloads, and therefore determines how you actually structure certain pieces of your environment. Okay. And of course, if you have a security guy in your environment that says, I don't care what you do, this must be totally isolated from something else. Then in that scenario, you need physical isolation. Then you have no choice. You have to put 2 separate sets of equipment because you need the physical isolation. All right? And the last one is, do you need resilience in terms of single data center or multi-data centers if you have that particular situation? All right? So when we talk about workloads, what we are saying is look at all of this stuff, and from there, you can chart out what you need for your environment. Now, having said all of that, the nice thing about what we have done in Hyper-V is that you can switch between anything easily now, because you can live migrate anywhere. As long as you have 2 Hyper-V machines, you can live migrate between them. Right? It's no longer the same as in the past where it needs to be in a cluster and so on. You can just live migrate between 2 machines. Because of that, you can start it off with some simple hardware, and then when you decide you need something really more complicated, you can live migrate the whole thing into a cluster and get the high availability that you need. Okay.
It's also important to note that in the data center, if you've got these different requirements for workloads, it doesn't mean that every cluster in your data center has to be the same. If you've got some workloads, and we talk about the SQLs and the like, they could be on a cluster with some of the technologies which are going to benefit them, and then the rest of your servers could be on a more generic type cluster. Okay, networking. Now, networking is a very complex topic, and I'm not a networking specialist, so, but I do understand what I need to from a Hyper-V point of view. We can really, to simplify, we can kind of put it into these three groups. It's all about isolation of the traffic flows, and we'll talk a bit more about that in a second. So whether it's the physical or the virtual. Also, we need to look at the type of infrastructure, so whether it's standard Ethernet or other, which we'll talk about. And then it's about all the specific NIC offloads that are available to us now. Hyper-V 2008 R2 had a number of offloads. Actually, a lot of those have actually either been improved and have new names now or have been deprecated. So there's a whole lot of new hardware offloads that you've got to understand. And it's really about knowing the advantages of each one and which ones are relevant for your situation. So if we look at the different types of traffic flow that we've got the virtual machine traffic, and that's obviously the traffic that's generated by the virtual machines themselves. We've also got the cluster traffic, or basically the cluster traffic between the nodes in the cluster. And then we have storage traffic, so that could be iSCSI or CSV traffic. Live migrations is another traffic flow that we've got, and obviously that's migrating the machines between the hosts. And then we have the management, which is basically how we connect to the primary partition or the actual host itself. Now, when we look at this, we can kind of split them up into two types of traffic. And for the rest of the presentation, we'll basically talk about these two types of traffic. So the first one is really the tenant traffic. Okay, so this is the traffic that's created via the tenants. We don't have as much control over that as we might the other forms of traffic, because it really comes down to what the guests are doing. And if you're a host or anything like that, you'll know that sometimes you just don't know what the customer's doing. Then the second lot of traffic is really our data center traffic. So that's the cluster and the storage and the CSV live migrations and the management traffic. So the first thing we usually come to is, how many NICs do we need? We've seen all these different types of traffic. So it always comes up, how many NICs do we need? And then you've got to look at your hardware and determine how many that can actually support. And with 2008 R2, if you talk to most people in Microsoft and in the industry, they would have said, it's Microsoft's recommended practice that you have separate NICs for the different traffic flows, because you were kind of using 1 gig interfaces, and they could easily be saturated with the traffic that was going over them. And it was always, depending on your security policies, there might be requirements for you to kind of separate the data center from the tenant traffic. So in a small business, separating those two probably might not be required. Whereas in a hoster, keeping the data center traffic from the tenant traffic might be one of these security policies that they've got in place. With Windows Server 2012, we can actually have like a converged network card and run all of those networks through that single card through a Hyper-V switch. And we'll talk about that later. But you're all familiar, well, maybe you're not all familiar, but when you go in and attach a physical NIC to a virtual switch, you've got that little tick box which says, use this network for management, right? Okay, and you get one network kind of presented in there, and you can give it an IP address, and you can actually use it for management purposes. With 2012, through PowerShell, you can actually do multiple, and we'll show you what that looks like in a diagram. And so you can actually separate all those different bits of traffic into different networks, all going through that Hyper-V switch into the physical NIC. And then it gives us the ability to, through that Hyper-V switch, to use port ACLs and quality of service, DCB if we've got hardware quality of service, and it just helps us to enforce that isolation. So, what do we need to run it on? We'll kind of start from the bottom, because Hopefully 1 gig will disappear soon. But there's still people out there with 1 gig, in their servers, a number of 1 gig network cards. Really, in many cases, it might still be suitable for your environment. If you've got a small environment, okay, maybe just two or three nodes, and the workloads are quite small, then you're not going to generate enough traffic to saturate those network links. So you could very well still go with 1 gig ports. And from a cost point of view, it's obviously very cost effective. As the workloads grow and the amount of traffic that travels across those networks increases, then obviously the requirement for more throughput is required. So then we get into 10 gig Ethernet. So obviously, great performance, and it's on Ethernet. So we can link this with RDMA and get significant performance increases with SMB3. And quality of service, like I said, we can either do it through the Hyper-V switches, but if you're using DCB or data center bridging, I think we've got another slide which kind of tells us about the acronyms that Microsoft is so good at using. Then you've got hardware quality of service. And also a lot of the new offloads are available on those. Then you've got InfiniBand. Is anyone using InfiniBand or seen InfiniBand in the wild?
One.
A few. So obviously the performance shoots up going from 10 gig. Usually when something like that happens, price shoots up as well. So it's something you've got to take into consideration. Also, you're not using your same fabric that you're using for your Ethernet versions of the software. So very high performance, low latency. Okay, so hardware offloads. Okay, so we're just going to run through what the different offloads are now, and just kind of give you a rough idea, what situation you might use those in. So you can see here we've kind of separated some of that network traffic there, and then we'll just kind of assign some of these different offloads just so you get an understanding of where you might use those different offloads. So, hardware quality of service is usually what we use for DCB. And not obviously all 10 gig Ethernet cards are not equal. Some cards you'll just have a single port and you won't be able to apply quality of service. Some cards you might get like 2 ports with a number of virtual adapters, and then you can go into the adapter or into some kind of configuration utility, and you can apply weighting and maximum bandwidth and stuff like that. So usually we could use that at the storage layer for the storage traffic. Also things like live migration and the management network. Okay, yeah, thanks. Yeah. Got to click up there. Yeah. RDMA or remote direct memory access. Now with this, we can get significant performance increases with SMB3. Obviously, this is a 2012 feature, so SMB3 needs to be on all parties that are kind of engaged in this communication. But we can definitely see significant performance increases. And especially if you, we'll talk about it later, but if you're moving to file servers as your storage, then RDMA might be one of the things that you use for this. RSS and RSC. So RSS is really taking all that incoming traffic and distributing it over all the cores in the server. So rather than just, you get traffic in and all maybe hits one CPU and that doesn't scale very well. So obviously this is helping with the scaling of the machine. We'll basically spread that kind of utilization across all the cores in the processors. And RSC, basically, if you have a lot of small packets coming in, it'll coalesce them together, and then it will basically work with the larger file, which is obviously more efficient. Virtual machine queues, it's very similar to RSS. So with Hyper-V originally, all traffic that came in was kind of, mapped or directed to the VMs through the first core on the processor. So it didn't scale well at all back in the original Hyper-V days. Then they came up with VM queues. Okay, so they actually made a number of static VM queues, which, as information was coming in, it would use a number of the cores, but not all, and it wouldn't, if the traffic kind of decreased, then the amount of queues that were available wouldn't decrease. It was just always the static amount. With 2012, it's dynamic, so the more load that comes in, the more traffic that comes in, the more amount of queues that will be available, and that means it's basically mapping that input to more and more cores, so you get more and more scalability. Because you don't want one core basically going through the roof, because it's basically managing all this network traffic. Guest IPsec task offload. So if you've got guests which use IPsec, if you've got a network, in your network you use IPsec. Anyone using IPsec here? The odd few. Sometimes, I'm not sure whether New Zealand hosters do it, but often in overseas, when customers are starting to move to hosted private cloud or something like that, yes, they trust the hoster, but also they want to make sure they've got a bit of isolation in their network as well, so they might use IPsec. With this, we can turn that on, and we generally turn it on the tenant NICs to basically offload all that processing that's happening on IPsec to the NICs rather than the processor. And it just means, we're freeing up the processors for the workloads rather than managing the network. Single root IO virtualization, SRIOV. Do you want to talk to that one?
Okay. So basically, SRIOV was developed by Intel, and what happens in that is that it makes a physical adapter appear to be multiple virtual adapters, up to a maximum of 128, and most of the current devices have about 16 or so that they can do. And what it will do is that once you have that enabled, it bypasses the Hyper-V switch totally. So whenever traffic comes in and the physical adapter gets it, it sends the traffic straight away into the virtual machine. It doesn't pass through the switch at all, which of course means that you lose everything. All the QoS stuff, all the bandwidth management stuff and everything is no longer there because the switch is no longer there to control it for you. So everything just goes straight through, and therefore, on the SRIOV portion, we have to do our own extra management. But the performance is really great out of that one.
So again, that comes down to the workload question. Do your workloads really need that type of performance? Just one thing to note here, you really need to make sure that your, oh, pardon me, too much talking today. You really need to find out what your hardware is capable. So if you are in the habit of going, oh, I'm going to build something, I'll just buy some hardware and then try and make it fit, then you may not be able to obviously light up all these things. So you have to go through, figure out the workloads, what kind of NIC offloads or hardware acceleration am I going to need, and then make sure you go to your hardware vendor and see if it's going to be possible. Because obviously you're going to have to see if the blades you're using are going to have mezzanine cards for SRIOV or whatever. So you just need to make sure that the hardware is actually going to match those. And with that, apparently you need proper BIOS support for that as well. So everything kind of needs to be at the right level. And something is... So it's really, it's like a trade-off. Okay, so you need to trade off between raw performance and the flexibility and scalability. So if we look at the ones that are around flexibility and scalability, it's the extensible switches, it's the network virtualization, which we're not really going to cover today, RSS NIC teaming or LBFO, which often gets called, VMQs and IPsec task offload. On the other side of it, your raw performance is RDMA and SRIOV. So often, yeah, like I said, when we're looking at the storage or connecting to your storage through file servers, then RDMA or SRIOV might be the type of technologies you use. Okay, are separate networks really needed? So obviously, you know, if you go back to our old guidance, and we're kind of covering what we've kind of mentioned before, but you know, there was always this requirement for at least 4 NICs, okay? And so whenever we come in to see you, we'd kind of encourage you to have as many NICs as possible, and then you go, well, I need fault tolerance, or you know, something like that, or you know, certain levels of resiliency, so okay, 4 turned into 8, or maybe some you didn't need to have fault tolerance, so it turned into 6, or whatever the case may be. So how many separate networks are really needed? So are 4 networks actually required? So the answer is no. Pardon me. Sorry about that. Should have let you know I was going to cough out. Theoretically, clustering can work on a single network. Okay, so you could have a single network and have Hyper-V, you know, a couple of machines and have all the clustering working. Is it recommended? And yes, it is recommended, and the isolation is recommended. And especially if you've got smaller NICs and there could be quite a lot of throughput, then yes, it is recommended. But this is all really changing these days with the NICs that are coming out. When you've got a 10 gig converged Ethernet card, which, you know, you've got so much throughput and you've got so many virtual adapters which have been presented by it, then do you actually need all those separate network adapters? So what really matters? So if you ask the clustering guys back at Redmond, they'll say resiliency and quality of service. So there's some traffic that's, you know, if you haven't got enough bandwidth available for it, it could cause problems. So a perfect example of that is, you know, your cluster, your intra-cluster network communication. If that is on a network which is saturated, then there's a possibility that the cluster might think that certain nodes are down. Then all of a sudden you get into a position where, you know, machines are failing over and you can get yourself into quite a situation. So, you know, it is very lightweight, but it is very sensitive to latency. So we need to make sure that there is that quality of service. So like there's multiple ways we can do it. We can do it through the traditional way which we might have told you to do in the past, which was through multiple network cards, or quality of service or the like. Also on the resiliency side, obviously multiple network cards again, or teaming. So, what's our priority? So there's the 5 traffic. Hazard a guess, what would you think would be, you know, the most important traffic? You know, if we're doing quality of service, what would you kind of make sure is kind of at the top of the list? There's no right and well, there's some right and wrong answers, and some are debatable. Okay. Anyone want to? Virtual machines. Cluster. Okay. We've got iSCSI in here. So this is one of the ones that's debatable. Some people would say, you know, the iSCSI should be at the top, because if your storage network isn't working, then your virtual machines aren't going to be working, and then forget about it.
More importantly, you lose data. Okay.
Yeah.
So I would say it's not just iSCSI, but it's any data traffic. That means the part that stores your VHDs is probably the most important, because that's the one that if you lose it, you lose your data. You don't want that. Okay.
Next one we would say is that cluster, or that intra-cluster traffic.
Right. You lose that one, you got no cluster.
Yeah. Right. Or the cluster will get itself into a situation where it thinks nodes are down, and if you haven't configured it correctly and you've got an even number of servers, yeah, all kinds of things could happen. Okay, so you need to make sure that that's got high priority, especially if the network's getting saturated. We'd probably put virtual machines as next. Obviously, you want to start making sure that, okay, we've covered the storage, so the virtual machines talking to their data, the VHDs on the storage layer. But then the next point is making sure that those virtual machines can talk amongst themselves and talk out to the network. Next, we'd probably put host management, because you're going to want to be able to manage your hosts. And then last, we'd probably put live migration, because live migration, well, okay, if you've got any kind of issues up the stack, then you'd probably forget about doing live migrations for the time being. So cluster shared volumes. So it is CSV version 2. We're just going to briefly touch on this. And it's more around the fact now that it uses SMB multi-channel. So I've actually working with a customer, they're in the room, and we kind of set up our network so we had all these different traffics kind of on separate networks, not physical networks, but virtual networks that we'd created. And we did our testing. We went and tested live migrations, which, by the way, now you don't actually have to create a virtual machine before you can set what network takes live migrations. You can do it before that. You can actually use PowerShell to do it as well. So we tested that, yeah, started live migrating machine, and yes, we looked and we could see that it was using that network. Then we decided that, we'll go back and do some stuff that we used to do in the day, because this was they're a tech customer. So they were kind of doing this before everyone else was. And we made some adjustments to the metrics to make sure that this was the network that was going to have, the CSV traffic. And so then we put a machine into redirect mode, and we noticed that it wasn't really just using one network, it was using multiple networks. So what was happening is we had 2 private networks, and it was actually using both of those private networks to do the CSV IO redirection. And it actually performed really well, because obviously SMB 3 performs far better than anything SMB has ever been able to do. And even when we put it in redirected mode, that machine with no connectivity to its storage worked without a glitch. Anything else on there? No, it was mainly that, just to be aware of. So the question does come down, and it's a question we're kind of asking ourselves: do we need to go and set those metrics? Lloyd thinks so. So what Lloyd says, Lloyd Peters is always right.
You just do that first to make sure that you are setting certain priority. That's all. Doesn't mean that you always have to do it. Okay.
Lloyd, if you can just talk about quorum.
So the new cluster, how many of you have heard about dynamic quorums? None. All right. What we have done is that whenever you set up clusters in 2012, there's a little process that will run every 5 minutes, and you'll check how many machines are currently available, and if there's a lower number than what it thinks that it should be, it actually reduces the majority needed to keep the cluster working. So when you do that, it means that, for example, you start off with 64. Normally, the moment there's 31 machines running, the whole cluster will go down. What happens now is that if you slowly lose machines up to the point where you lose to 33, it actually recalculates, and it says that after you only have 33 running, it will recognize that you only need 17 at that point to actually keep the cluster going. And you'll recalculate quorum so that as long as 17 are running, the cluster will still stay up. So what it means is that you have the ability, if it goes down slowly, to actually be able to go from a 64-node cluster all the way down to 1 node and still survive. Okay. So that's what we have done. And that's what we mean here, allows for greater than 50% failure over time. It adjusts the majority needed every 5 minutes. So if you add more machines, it will adjust it for you again. And what it do is, we always recommend, try to keep one file share or one disk witness in there, so that when you have 2 left, whoever gets hold of the file share or the disk witness will be the last guy standing. Okay?
You'd be surprised how many people, well, some clusters I've seen which didn't, it was an even number and it didn't have like a disk majority or a file share witness. Or they had an odd number and then they had a disk witness and then they added a new machine and they didn't even think about, changing it. So, it was one of those things that, unless you were keenly aware that, you had to have this quorum model always in the right state, there was people that kind of let it get out of kilter.
So what it kind of looks like, if you see up there, you can change the ticks. So in other words, you can say that certain nodes, certain clusters, parts of the clusters, participate or don't participate in voting. So therefore, you can change the vote. So this is static. You make the changes yourself if necessary.
Okay.
Then the next screen shows you where you have a tick there that it says, allow the cluster to change it dynamically. So at that point, the cluster will recalculate depending on whether the particular Hyper-V host is up or not. All right. And of course, the question gets asked, what happens if I have 1,000 VMs, which I think today we are allowing up to 8,000. The last number given today is we can have 8,000 VMs running on the cluster. What happens if all of my machines die and I only have one machine left? Are 8,000 of them going to run on that thing? No. What happens is that you're supposed to set priority. When you set this, then the ones which have higher priority will be the ones that carry on running. The ones that have lower will get resources taken away from them. Okay.
Okay. We'll have to motor through this.
Okay. I'll do it fast. Okay. All right. So what we have done with storage is this. Basically, throw out everything that you used to know about SANs. All right. Look at it from our perspective now. Because we have found that SANs are expensive, you need to do a lot of work with them, you need to do a lot of stuff, but they do give you great performance. However, if you can put a whole bunch of this, you get equivalent performance to a SAN for most things. The larger the number of this, the faster everything runs. All right? So what we have done now is we have tried to reduce your cost performance ratio so that it becomes a lot lower. You get much better performance at lower cost. And what we have done is we have also made it easier for you to manage storage from Hyper-V.
Just to qualify, we're not saying throw out your SANs or forget about purchasing SANs. It's just you've got alternatives now.
Yep.
Okay, and depending on your cost constraints, there are much better cost alternatives.
Yep. Rather than always needing to buy SANs. Okay. Then, of course, you got vendor preference, existing investments, and how you actually want to scale your storage. So if you look at the various approaches, this tends to be the standard way that you do it when you are a very small environment. You put your disk together with your server, for example, or you just put them off a SAS attached drive. So a few disks in there. And then whenever you want to buy more servers, you buy more storage along with it. And then you run it that way. So in that scenario, you actually don't get high availability because there's no shared storage. Everything is separate to its own machine. All right? Now, the other type that you have is the one where we separate it out. Okay? So in this particular scenario, this is always used in most environments today. The one on the right is the one that's always used. You have a Hyper-V server, you have a SAN at the back end, and then everybody uses that. What we're trying to say is, look at the other one here. The one with Hyper-V, we go through a continuously available file server, and then we have a bunch of this with, let's say, 2 or 4 controllers in it. So it goes to 2 or 4 machines. And the more disk you put in there, you get a lot of performance gain, and you don't have to pay so much for your SAN. Storage costs have gone down. All right? So what happens in this case is you can grow your capacity as you need on 2 axes. That means when you need your more servers because you run out of computing power, just put more Hyper-V servers. When you need more file shares, all you do is just buy another JBOD enclosure, put another 2 servers on it, and just keep on using it. Okay?
Okay. And if you've got an existing SAN, there's no reason that the file servers are connecting via fiber, and then maybe the Hyper-V servers are actually connecting via the network. So, as you scale out your Hyper-V infrastructure, you're not having to worry about, fiber HBAs and fiber switches and stuff to actually hit the file servers. But from that point onwards, down to the storage, you can still use your existing fiber. So it's one of the options that are out there. Again, it just comes down to what your storage requirements are. Yeah.
Okay. The other thing we have done is something called storage spaces. Basically, any storage that you have locally attached to a server, you can then provision it like a SAN. And that's what we're trying to say. You take all of that in, get multiple disks, you can create your own RAID array, you can create hot spares, you can specify you want redundancy or no redundancy, that kind of stuff. And then you present it as LANs or as disk to subsequent servers, or correctly as file shares, which then Hyper-V can then use. Okay.
Okay, resiliency, we're just going to go through this quickly. I kind of mentioned at the beginning, it really comes down to the two approaches. You know, is the app responsible for resiliency, or is the infrastructure responsible for resiliency? If you build an app which, it's spread across multiple servers, and if servers die underneath it, the app will still keep running. So maybe it's guest clustering, or maybe it's a web app which is sitting in a web farm. Then it's usually the app itself which is in charge of the resiliency. If your app isn't like that, then you're doing the traditional infrastructure resiliency, where a server dies, then you'll move it across or start it up again on a new server. Okay, so let's look at some of these different configurations. So this configuration it's kind of what we call the traditional type of configuration. This type of configuration may be very well in line what you've already got in place. You could possibly add some extra stuff to the environment, light up some of the new hardware acceleration, but without having to re-architect your environment. And you generally use your traditional SAN storage. So in this instance, probably not exactly what I would see most customers having. Usually what we'd see is, those two joined, the Hyper-V switch going to that, and then these three going to this other team. So a lot of customers would do that, and then they might use their teaming software that comes with their third-party NIC vendor to actually provide those different networks. In this instance, they've basically got them all configured separately. So what could we do in this environment? Again, just as far as the hardware is concerned, having this amount of cards in a blade mightn't be possible. The only way you might be able to do this amount of cards in a box is through a rack-mounted server. So as far as scale and resiliency, for storage access, obviously that's where we can use the NIC teaming to get a bit of resiliency through to our storage if it's iSCSI. Just got to make sure that's your networking team that's actually doing the back end of that, doing it correctly, so it works right. And obviously RSS will just help us scale further. If you're going out to buy a SAN, make sure it has ODX. I'm not sure whether they're demoing that or talking about it. I'm sure they'll be talking about it in the storage sessions. I think Ben Armstrong is doing the storage one. But ODX, you can go from transferring the data between the machines at the machine layer or at the SAN storage layer. And obviously at the SAN storage layer, it's considerably faster. On the VM side, if we go to the tenant side, we can use NIC teaming to give resiliency there, and also the VM queues. Also with 2012, if we want some more flexibility and extensibility, we could put quality service between the actual virtual machines. So that's all done through PowerShell, or we can use switch extensions. So if you're a Cisco house and you want to be able to manage your virtual switches like you do your physical switches, then you could use the Cisco Nexus 1000V switch extensions, and then your networking team would be able to basically monitor and configure as they would all the rest of their switching hardware. And network virtualization, which I said we're not really going to touch in this session. Like we said, if you chose to use SRIOV in some circumstance, this would be more for those bigger workloads. Obviously, you lose all the functionality that you're going to get for quality of service and those switch extensions. So using SRIOV means you're not going to be able to use the likes of the Nexus extendable switches. So there are trade-offs. Converge with file server. Yeah, that's you.
Yes. All right. So when you have a converge configuration with file server, what we are basically saying is we put two separate networks, usually. So one of them is for your cloud infrastructure, live migration stuff and so on. The other one is for tenant. So your tenant traffic goes on a separate network. And then, if necessary, you can put NIC teaming between them. You can also do...
No, you want to stay back? Okay.
Oh, okay. Then what we usually use that for is things like small to large data centers, especially if you don't have a SAN or you want to decommission your SAN. Because in that case, when we go to the next part, you can see where we don't really need a SAN. Okay? Thanks.
Why don't you do it? Yeah.
All right. So let's look at this particular environment. You can see that the network that we are using for tenants is separated. So they have their own network, and that's the tenant network. And then we do a converged network for your file servers and your Hyper-V servers for management traffic. So in that scenario, you're guaranteed quality of service on that side, and you can do whatever you need for quality of service on the tenant side separately. Okay? The storage, as you notice here, can be by itself over its own, for example, FC, fiber channel, or else you can use iSCSI. Or if you are using file servers with the locally attached JBOD SAS enclosure, then they can just go straight in there and you don't need a network for that one. All right? So if you use this method, you use the storage spaces stuff that we talked about. So in that case, you're actually creating a JBOD array. And then from there, you do all this other stuff on top. Basically creates a SMP file share, which can then be used by the Hyper-V server. All right? So if you don't want to do that way, you can also use hardware rate controllers to actually run the same thing. That's out to the same stuff. At the end of the day, you want to get back to an SMP file share. So with that, your Hyper-V server can see it. So if you think about this, you can actually have two separate storage clusters to do that kind of stuff. One of them with RAID arrays and so on, the other one with just another bunch of disks. And then depending on how many disks you put in there could be different performance trade-offs. Then you can choose which, you can storage migrate the VHD from anyone to anyone, depending on how much money they want to pay or how fast you need a VM to be. All right. Okay. Then you can also do the part with the SAN. So that means you front-end the SAN with an SMB3 file share. Now, why do we do that? In that case, I only need to pay from the SAN perspective for HBAs and fiber channel cards and fiber channel ports only at the file server end. Whenever I expand the Hyper-V server, I don't have to put in new HBAs because HBAs are expensive, right? And if my fabric switch is running out of ports, it's hugely expensive to buy another fabric switch, right?
I think far as scale is concerned, when you look at the one which a couple back where you're connected to the JBODs or you're connected to the fiber, it will kind of determine, the decision might need to be made around, okay, how big is my cluster going to be? Because there's only going to be a certain amount of SAS connections to that array. How many do you?
4. You can
Four.
buy enclosures with 4. All right. The thing is that what you want is enclosures with large amount of disk, because the larger the amount of disk, the more IOPS you can push through.
So as you're scaling it bigger, it might not be an option, but if the smaller the environment, obviously this is a much more economical version than having to go out. And I remember, I come from partnerland, and I used to do VMware way back in the day, and the biggest thing is I'd go in and I'd say, okay, yeah, virtualization great, and then they'd see the storage costs. All they had was like 2 or 3 servers, but then there was this massive storage cost. This really drives down those costs, so they can get all the features and functionality and everything that's we kind of promise through private cloud and the Hyper-V infrastructure, but for a fraction of the cost. So the cost barrier is kind of slowly deteriorating.
Okay, good. All right. So basically, if you use this method where you actually put QoS and so on the Hyper-V server, you can then use our standard PowerShell commandlets to actually do the QoS for you. All right. So therefore, you don't have to worry that even though it's a converged network, you will not be able to keep up with the traffic, because by using QoS, you can guarantee enough bandwidth given to the various networks you need.
This slide deck will be available to download, just so you can remember all these things once we get to the end of it.
Right. So in the same way, once we have that, you can also do QoS on the file servers as well as the Hyper-V servers, because they're all 2012 servers at this stage, right?
The main thing to note, if you just go back, is that RDMA and NIC teaming can't be used together.
And same thing with SRIOV.
Yeah.
SRIOV cannot be used with NIC teaming. Okay.
So
SRIOV cannot be used with NIC teaming on the physical adapter. You can use them on the gas adapter.
Yeah. Okay. So it's just, again, it's one of those things you have to navigate. You just go, oh yeah, okay, I want resiliency and I want RDMA. You know, you can't have both.
Yep.
Unless you do this next slide.
All right. So if you do this one, then you're using RDMA with 2 data center NICs, and in that scenario, you actually get everything you need because the RDMA capability with DCB comes along with that. All right. So that's yours.
So most of this is really around, like I said, figuring out your workloads, okay, and then really just understanding. I would say get the simplest solution, but also meeting all your performance requirements, okay? Because some of those ones that we just looked at there, you know, towards the end, they were relatively complex type configurations. Whether you'd actually need those, probably not. But again, it's going to come down to whether you need resiliency, whether you need that high throughput. That will kind of determine what of those models you might use. Hence, if you get your hands on the deck afterwards, it'll help you through those. Okay, so if we looked at converged network, this is really good for small to medium business, and it really helps us drive down the storage infrastructure costs. And it's in a scenario where there's either no SAN or you're kind of coming to end of life and you're thinking about decommissioning it. So let's just go to the diagram, probably the best thing. So I talked about earlier the fact that you could add a virtual switch to adapter and it would give you this one network. Okay. If you don't do it via that method and you go and use the PowerShell commandlets, which really we should have got for this, you can then go and create all these different networks through PowerShell. So you can get your separation of all those networks by creating basically these virtual networks off your Hyper-V switch. And the important thing about that is then we can put port ACLs against it, so we can make sure that certain networks can't talk to other networks, and we can also put quality service. So our cluster and storage might have a different priority from the live migration, and we can do that all at the Hyper-V switch layer through PowerShell. In this particular instance, we're getting to do it to a bunch of disks, just a bunch of disks. Yeah. So this is a converged network, and so whether it's DCB or whether, if it was DCB, it's possible that the network cards would actually present a number of networks themselves, like virtual networks. In this instance, you're just getting presented one NIC, but you want multiple out of that. So like I said, yes, we can assign ACLs and QoS, and yeah, they're just VM NICs. We've already talked about that actually. One of the main things you've got to do, obviously, the traffic comes out of the physical device and hits the network, and to make sure that it can actually talk to the network, you're going to have to connect, configure VLANs, but that's kind of standard practice with that type of stuff. One too many. Do you want to talk about the storage? You're the storage guru.
So in this particular scenario, you're doing the same thing here. You're putting the storage up to a CSV level, but within the Hyper-V server. That means it's locally attached to the Hyper-V server. So we are not using file shares anymore, correct? So in this scenario, it'll be shared. So the CSV is shared among all your Hyper-V servers. So what happens here is that you're actually creating the CSV out of locally attached disks on the server themselves. Okay. Mm-hmm.
From the network side, this you'll probably find is going to be very common for customers because of the hardware they've got. Okay, you might just end up with one of these NICs, or maybe they've got a 10 gig, which is like 2 ports, and you'll just team those. So it kind of, as it's going out of the blade chassis, it's kind of going out to 2 paths. So you might find the network side of that is quite common. The storage side, again, it's going to be on the scale of the environment. If it's a small environment, then you might have this type of configuration. But in this configuration, you could also have the fiber connectivity. Also with that CSV traffic and storage traffic, yeah, we could put another card in and use that specifically for cluster storage.
So
direct attached.
This is our final one, and this is basically used in 2 environments. the smallest and the largest. So the smallest environment, in this case, for example, dev and test. We don't care about HA, we don't care about anything. So all we do is we direct attach the storage. We don't have any shared storage, it just leaves on one server by itself. The other way you use it for is for a large cloud, in an environment where every single app is resilient in itself. So I put an example here, which is Active Directory, Exchange 2010, SQL 2012. Notice I didn't put SQL 28R2 because 28R2 doesn't have that capability. Only 2012 and above, SQL 2012 and above has that. What it means here is that each app can survive the loss of any of its servers and still carry on without losing data. That's the way it's been designed. And when it's designed that way, we can then put a whole cloud data center exactly like that. Right? So if you look at this, all it is just one Hyper-V server, direct attached storage. I don't even need to put anything out of it, because if the whole host dies, whatever VMs that were running on it dies, but the application carries on surviving.
So I've seen data centers like this. I won't mention what data centers, but what they're running on them, the application is fully resilient. So all the hardware it's single NIC, it's single power supply, single processor, everything is single. They haven't spent any money on redundancy or resiliency at all.
Right. And of course the question asks, why do you want to make it virtual? Why not just make it physical? The reason behind it is so that when you need to, you can still patch the thing or change it. When it's not a faulting thing, you can just live migrate the VMs off and then do stuff on the host machine. That's the only difference.
So, if anything, all these new features just make it, there's a whole lot more decisions you have to make. So, we've just had an hour, and really it's kind of mind-boggling when you kind of think of all the different decisions you've got to make. But there are, if you go back to the beginning of the deck, if you get the deck and go back to the beginning of the deck, it's kind of clear that certain functionality is good for certain situations. So if you look at all your different requirements, if you look at what your workloads are going to be, then you can start matching those up with the different technologies you want to go and use. So thank you very much. That's our time. If you've got any questions, feel free to come down and talk to us.
Not pointing at me, right?
Yeah, Deloittepedia. Yeah.